present for you from Tamika. She made it at school, and she said this is for your students. So there you go. It's got some nice color in it, I think. So please have your math book out. And if you haven't already labeled the things we've covered so far, now would be a good time to do that. Get some paper, Post-it notes, if you have them, and go to page 189, write the word exponents, and put that in page 189. So if you ever need to reference that. Then on page 203, write scientific notation, and put that piece of paper in there in case you ever need to reference that or go back to it. Then go to page 407, write coordinate plane, and put that paper in there. And that brings us to today, which is page 481, polygons and transformations. What I'd like you to do is to please put a piece of paper in there, but we'll leave it off to the side now because we're going to use it. So we did a little bit of this on Friday where we looked at points and we plotted them and we were able to create a shape. So I want you to read this page, look carefully, and then answer the question on the Ed puzzle. So read page 40 and 481. All right. You can see we can create other shapes too. Look at page 482, read it carefully, and then answer the question. And last, what we can do, what engineers and architects do all the time, is they can solve problems by plotting these shapes on the coordinate plane. Maybe it's the top of a building, maybe they're planning out a city or a block or something like that. And we can use the X and Y coordinates like we did on Friday. So let's do some problem solving with this. So we're plotting a square on the coordinate plane, and we have these three vertices. Maybe we know these are the corners of the block we have to use. So we're going to plot the first point at 1, -3, next point at 5, -3, and then 1, 1. Well, where would that fourth point have to be, right? We know it's probably going to be over here somewhere, and we can calculate that exactly. What I want you to do is take a look at this down here, and then see why I know that these are 4 units apart. A couple ways to do that. You can count 1, 2, 3, 4, or you can just go to the values up here, right? The points, 1, 1, and 1, -3. You'll notice the ones are the same. Because the ones are the same, that means that that X value is not going to change, right? They both stay on this X value. The difference is how far up or down the X value they are. In other words, the Y value. And you'll notice the Y value of A is -3, and the Y value of C is 1. Now, I'd say the biggest mistake I saw people make on Friday was they said, oh, -3 and 1. -3 plus 1, that's -2. Well, that's wrong. Because first of all, you can see that this is not 2. You can also see that distance isn't negative. We don't have a negative distance. What you actually would do is say 1 minus -3, which is +4. The other way to do that, in case you got confused by that, is to simply say, well, if I'm at -3 and I want to go to +1, that means I have to go up 3 just to get to 0 and another 1 to get to 1. So that's 1, 2, 3, 4. So if you think of it logically, you can also use your KCC skills, but try to understand how distance works on the coordinate plane by continuing to look at both methods, counting boxes and the subtraction of the coordinates. You can see for A and B, it's a little simpler, right? For A and B, the Y value is the same. That means they stay on this plane, but the X value goes from 1 to 5. Well, how far do I have to go from 1 to 5? 4, right? 5 minus 1 is 4. So that tells me that this is 4, this is 4. That means I'm going to have to go 4 from here and 4 from here. Take a look at the next page, 484, and answer that question.